Hi guys, it's a hot one out there. It's about 110 degrees here in Vegas, so it's appropriate to talk about cooling systems today. This is an old build from California, and he actually has not been having any overheating problems, but he wants to upgrade to the Camaro SS fan. So that's what we're doing here, and I'm going to explain some of these components. Here's our new single pass double header radiator, and like we've discussed in the past, this radiator may not look fancy, but it's solid. And let me tell you the technology in it. We got two headers on each side. So where these tubes go into the header, there's not only one plate, there's two to support it. This is heavy-duty truck tractor technology. You'll notice this radiator has mounts for the Pentastar, stock early JK 3.8, and Camaro SS fan. Down here at the bottom, you can see it's slotted, has multiple slots for different fans, and it has the outlet size designed for the LS engine. One of the advantages of the single pass over the dual pass, and let's take a look at that. Here's our early dual pass radiator. Actually, this is not our early, this is a later dual pass radiator. They actually started out life like this. You can see that this is a dual pass because both outlets are on the same side. There's a plate over here that separates it, so as the water comes in, it goes across and then back across again. What this does is it gives the water more time in the core to dissipate its heat. What's really important is the thickness of this radiator and the airflow, meaning if you make these radiators thicker and thicker and thicker, then it's harder to get the air through it. So if you go with a 5-row or a really wide 4-row or 2-row, then you might have a lot more capacity, but if you don't have the air to go through the core, you're going backwards. In fact, this vehicle had exactly that problem. Years ago, it had a 5-row radiator in it. It was really thick and it was running hot. The radiator was built down in California. We installed this radiator, and this radiator actually is still doing its job today, and it's really not leaking. If you look carefully up here in the corner, let me see if I can get some light on this. Can you see where it's starting to sweat? Right there, where the tube meets the header. And that's pretty much it. The rest of the radiator is clean, and it's not even leaking. You can see that tube right there is starting to show a little bit of wetness, but it's really not leaking. It's more like sweating. So for as old as this radiator is, it's actually doing good, and it could probably go longer, but we've decided to upgrade it to the new radiator, and we're going to show you why. So over the years, we made the radiator stronger and stronger. We started to weld the seams, gusset the seams, strap it, but we kept having a problem with the tubes tearing up. Again, if you look here, you can see where the tubes are getting wet. Let me get some light on this. Can you see how those tubes are sweating? Not really leaking, it's more like sweating, and over time, this radiator is twisting and flexing. Why is it twisting and flexing? Well, look at some of these Jeeps. They're heavy, they got large tires, some of them have roof racks, and as the body twists and flexes, so does the radiator. Here is a stock radiator. One, it's got a really thin core, I think it's about 35 millimeters. Two, this has got plastic tanks with crimped aluminum construction and a rubber seal. That is a lot more flexible than a solid aluminum radiator that's been welded together. Now, non-ferrous metals like this aluminum don't tend to like to flex a lot. They will break if they flex. So what's happening is, as your JK is going down the road, especially off-road, that joint right there is flexing and it's getting torn up. So now we have this header and we have this header. In addition, we removed all the strapping and gusseting, and that allows the core to flex better. So in addition to allowing this core to flex easier by not having the dual pass design that is stiffer and more rigid, and having the quad headers, so there's two on each side, we're also running this spring mount. So as your JK goes down the road and flexes and twists, this spring mount or this compression spring will take up some of the slack when the radiator tries to stay. Think of this radiator like a brick. This radiator doesn't want to flex. So anything we can do to allow the radiator to stay a brick and not flex with the chassis is going to help to keep from tearing up that joint. And I can say that this design now has been around for, well, we're on our third batch, 50 radiators per batch, and we haven't had a single one leak yet. Now let's move on to the condenser. One of the reasons I'm upgrading this radiator, even though this vehicle was not overheating, is that it had this condenser in it and it had this fan in it. Now this is a standard JK automatic transmission condenser. Down at this bottom part you can see where it looks different and you have these lines coming off. That's your transmission cooler. It's a very poor design because this transmission cooler is now behind the bumper and it's not getting airflow. Getting a little bit of airflow from the fan, but the early JK fans were not very powerful. So what ends up happening is Chrysler uses this high efficiency fin. You can see how dense that fin is, or how dense these fins are, and it tends to trap dirt and dust. The transmission would get really hot. The 42 RLE was not a very efficient transmission, and it would spit fluid out the dipstick tube. Then your JK could catch on fire because it would get on the exhaust manifold. So Chrysler fixed that real quick with the Pentastar, and they put a sizable transmission cooler in front of the radiator, which really works well. But this is pretty much a wasted space right now. So what we like to do in our conversions, all of our conversions get this condenser. One, the fins per inch has been opened up, and that allows debris to go through easier and doesn't plug up as easy as the Chrysler condenser. Two, we've removed this bottom transmission cooler. You can see here it's shorter, and what that does is it opens up this space to allow more air to flow into this radiator. So you want to upgrade to a manual transmission condenser if you can. This is out of a manual transmission JK. It does mount a little bit different. These only have 3 mounting tabs. Most of the automatics have 4, but without this lower section you don't need the 4th one. Now let's take a look at the fan. This is a Camaro SS fan. This is my favorite fan. Look at these cables, and I'm not going to call them wires because these have got to be about 6 or 8 gauge. These fans can pull a lot of amps. I'm going to say 70 amps plus. They can move a lot of air. This fan has a 19-inch blade in it versus a 17-inch blade in the early JK fans. You can see how much of the core this fan covers, and by doing that it does a few things. One, the larger blade is more efficient, so it can run at a lower speed and pull more air. Now I do find that this fan is quieter than this fan. This is the Pentastar fan, and we'll talk about that in a minute. So I do find that the blade design and having additional blades runs quieter and pulls more air than the Pentastar fan. Two, having all this exit area for the air to go through when you're going down the road, and we've got these little flappy doors, means that when you go down the road, that air can pass through the fan more efficiently and then through the radiator core. If you have these little 12-inch fans, a couple of them, and all this area is blocked, then you're just blocking air from going through your radiator. Guys don't realize that when they put multiple fans in. But you want as much air to flow through this when the fan's not needed. So when you get going down the road 70 miles an hour and air's flowing through here, the fan's pretty much gonna slow down or turn off. If you have the little fans screaming, little 12-inch fans screaming at a high RPM, then when you get going down the road and all this is blocked, you're not going to have the same efficiency as you would with this fan. Now it's also important to make sure that you don't obstruct the grill. And I don't know how many times we've talked about this. Now this is an old build, and this has got a Warren power plant. You can see when the air hits this, it's going to go right over the hood. And I did notice that while this Jeep ran cool, the AC condenser pressures were higher than I wanted them to be. And that's pretty obvious why. This condenser is pretty much plugged, and we are running a Pentastar fan, and we're going to talk about that now. This Pentastar fan also has a 19-inch blade. The problem with this Pentastar fan, in my opinion, is the control. I think Chrysler had problems controlling it. GM controllers have problems controlling it. Everybody has problems controlling it because it is a 10 hertz inverse pulse width modulated fan. The rest of the world pretty much goes with a positive pulse width, about 100 hertz, 121 hertz for the Corvette. So if you look at this Camaro SS fan, it pretty much follows convention. The higher the pulse width, the faster the fan goes. About 100 hertz, that's what Chrysler's running on the new JL and the JT. They corrected the problem with the Pentastar fan. This Pentastar fan went with a 10 hertz control, which is really oddball. Then they made it inverse. So the higher the pulse width, the slower the fan goes. And what that does is it makes the control of this fan very iffy at best. Now, if you look at things like coolant temp and AC pressure, we can program for this fan to control those things. But other things in the background, or riders as I call them, like transmission temperature, intake temperature, we can't program. Those are embedded in the operating system. So what happens is if your trans temp gets real high, it'll put a positive pulse width into it, and that'll slow the fan down. So your transmission's starting to overheat, it'll run away, it'll turn the fan off. Not so with the Camaro SS fan. With the Camaro SS fan, you're controlling it for engine coolant temperature, transmission temperature, vehicle speed, intake air temperature, AC condenser pressure, all these things. So we're going to replace this Pentastar fan with the Camaro SS fan, and what's going to happen is this fan is going to only run as much as it needs to get the job done. A lot of you know that the Hemis and other conversions run this fan wide open or at some high speed, and that can be really annoying, especially with the windows down and you're trying to talk to somebody. So we don't necessarily like to support the Pentastar fan. Can we? Yes. But this fan is 100% controlled by the GM computer properly, the way it's intended to. It's a more powerful fan in my opinion. It's a quieter fan in my opinion. And as you can see, our radiator, and this is an old radiator, but you can see it still has the multiple mounts. There's your condenser mount there. If you look down here, it has the multiple slots for both the Pentastar stock 3.8 and the Camaro SS fan. So these radiators can pretty much accommodate any of these fans. So we're going to assemble this now. We're going to use our dual header. So it's got 4 headers, single pass radiator. And by the way, guys, remember we were talking about the thickness of this? This is 52 millimeters here. This is about 42 millimeters. And what we discovered is going to this slightly thinner core not only gives us more room, but it allows more air to flow through. And by using that in conjunction with our off-board coolers, we get better efficiency, meaning this vehicle had a really thick core in it and it couldn't get enough airflow into the engine compartment, because remember, the engine compartment's under high pressure, outside of the engine compartment's under low pressure. So we're trying to pull low pressure air into a high pressure zone, and it's hard to do. So by going to this slightly thinner radiator, we've had really good results, because now this powerful fan can pull more air through it and actually transfer the heat out of the water. So we're going to assemble all this into a module, and then we're going to drop it into the chassis. We're going to use our quad header single pass radiator, manual transmission AC condenser, and Camaro SS fan. And with this setup, guys, most JKs are set. You don't really need to do much more for your cooling. Of course, you got to run a transmission cooler, but if you have an average JK, that's pretty much all you need. If you have 1 tons 40s, you got a black JK in the desert, then we do have some off-board options, and we're going to talk about that in another video.